Histograms are a very useful graph, so in this video we're going to learn how to interpret them. A histogram plots a single variable. The key idea to remember when interpreting a histogram is that it shows you the density of observations relative to that variable. By that, I mean they show you what values of the variable are common and which are uncommon. We typically summarize this density by describing the overall shape of the pattern formed by the bins of the histogram. If you imagine joining the tops of those bins with a line, you will see what I mean by shape. Here are some common examples, and the words we use to describe them. First, it's useful to describe how many peaks are in the histogram, which we call the modality. If there's one peak, we call the histogram unimodal. 2 peaks is bimodal, and multimodal means more than 2 peaks. If there are no clear peaks, then we describe the shape as uniform. If we have a unimodal distribution, then we also want to note whether the data is symmetric around that peak or not. We call this the skew of the data. The ends of the distribution are called the tails, and we say that the distribution is skewed in the direction of the longer tail. Okay, your turn. Pause the video for a moment and decide how many distinct peaks you see in each of these distributions. In the first histogram, it might appear that there are 2 peaks. However, don't be misled by a little bit of variation in the bars. We want to look for the overall pattern, which seems to be just 1 peak. I suspect that if you were to make each of these bins a little wider, then this jaggedness would disappear. The second histogram is clearly a bimodal histogram, since we have one large peak on the right-hand side and a smaller peak on the left-hand side. In the third histogram, again, we have several distinct peaks, 3 in fact, and so this would be a multimodal histogram. However, there are no clear peaks in the histogram on the right, so this would best be described as uniform. Let's try again, but this time pause the video and decide if each histogram is symmetric or skewed to either the left or right. If we look at this left-hand histogram, we can see that the long tail of data occurs to the right-hand side of the central peak, and so we would describe this as right-skewed. Then the middle histogram, however, is left-skewed because the long tail of data occurs to the left-hand side of the central peak. And finally, the third histogram is a symmetrically distributed histogram. Histograms can also be useful for detecting outliers. Here we see that in both of these histograms there are bins to the right of the main body of data. The first graph has just a single point in the outlying bin, so we can be pretty confident in describing this as an outlier. However, there are several points in the outlying bins of the second graph. So when we see multiple data points in an area, this might be indicative of a real pattern rather than just an outlier. We would need to investigate this more closely, possibly with a different type of graph to be sure. So to recap, when you're interpreting a histogram, you should first describe the shape, and in particular you should characterize the shape in terms of skewness and modality. Another thing we might ask is for you to tell us where the center of the histogram is. In a histogram, this means where the highest bar occurs. And finally, you can also use a histogram to note the presence of outliers, if any exist.